So, our last lesson that we're going to look at dealing with statistics is going to be on what's called appropriate displays. And what this is seeing a set of statistics and choosing a way to visually display those statistics. And so, there's quite a few different displays that we can use. Some of them are going to be better than others for different reasons, and we'll talk about those once we look into them. With today's question, there will be more than one right answer sometimes. And we as long as we can explain how we would um, set up this display, then that would be good enough. So appropriate displays, kind of like what I just said. Um, Sometimes we'll need to choose different displays to show different statistics. Many of these displays will have more than one appropriate display. We just need to make sure that it is going to work for this situation and that we can explain or describe how it would look whenever we set this up. And then charts and graphs, any type of chart, any type of graph, a bar graph, a line graph, a circle, pie chart. Those are the types of displays that we're going to be using today as we decide which one is the most appropriate. Okay, so moving on. When deciding what type of display to use, we want to ask those three questions. What type of information is given? What do we want the display to show? And then how will it be analyzed? Analyze means how will it be, how will you answer questions about it? Or what are we going to talk about when it comes to this display? So really, we just need to make sure we figure out what are we trying to show and how are we going to do this. And so a lot of times, like I said, there'll be more than one correct answer. We just need to make sure it can effectively answer those three questions. So the different types of displays that we're going to be using today, these are the first four. So if we're trying to show like the number of items in specific categories, and these categories can be different colors, different pets, different people, different groups of people, we would show a bar graph. So there's each bar is a different category or a different group, and then we show how many times that occurs. A box plot, we talked about box plots earlier this week. It shows the measures of variation. So basically it's, how spread out is it? Are the numbers really far apart? Remember, that means if it's a really wide box, are they close together? It'd be a narrow box. It's also useful for very large sets of data because then we don't have to show every single number. Remember, box plots, we just show 5 different numbers, the smallest number, the Q1, Q3, the median, and the largest number. Okay, a circle graph, if we want to compare like percents, so I will write there, circle graphs are good for percents. If you want to get that down, because we're comparing part of something to the entire thing. So part to whole, we use percents for that. So a circle graph, we also call this a pie chart. Okay. And then a double bar graph, that's if like we're saying, well, 2 sets of data. So we're comparing the number of boys and girls that play each sport. And so we would have for soccer, we would have a bar for boys, a bar for girls. And then we would look at baseball, softball, a bar for boys, a bar for girls. So that's if we're comparing like different categories, but if there's 2 different sets for that category, not often used, but just need to make sure we know what it is. Okay, a histogram. A histogram is like a bar graph, except on the bottom, instead of a category, it would be a range of numbers. And so the equal intervals, this would be a range of numbers. So for example, we want to see the number of buildings in Indianapolis that are all from 100 to 200 feet tall, 201 to 300 feet tall, 301 to 400 feet tall. And so there would be a bar for each of those categories. The categories is not boy, girl, football, basketball, softball. It would be a range of numbers. A line graph shows a change over a period of time, and that you've probably seen that like on a commercial or something where it's like this, and then that goes up, down, up, like that. That's a line graph. It kind of looks like mountains a little bit, but that's showing change over a period of time. So like this is 2000 and this is 2020. And we're showing how something has grown from one year to the next. And so if we're showing change over a period of time, a line graph would be good for that. And then a line plot, it is like a dot plot, except instead of dots, it would be a line. So that's what a line plot would look like. So instead of having a dot for each number, there'd be a line that goes up. The taller it is, the more often it occurs. So showing frequency, how often something happens with a number line at the bottom. So similar to a dot plot. Okay, so those are all the different types of displays. So as we answer our questions today, all of our answers are going to come from that one of those. Okay, so we've got our first one here. Select an appropriate display to show the number of boys of different age ranges that participate in athletics. So there's not one for different sport, it's different age ranges. That's what we're comparing, the different age ranges. So for example, we would have like 10 to 12, 13 to 15, 16 to 18. So that would be the different age ranges. So looking back at our displays, equal intervals, a range of numbers, that is a histogram. Okay, so these ranges, these equal intervals or different ranges, that would be perfect for a histogram. And so we would use a histogram. And that's all we need to say for this. Sometimes it'll tell us to describe how we would set it up. For this one, we don't have to. We just say a histogram would be best. And then just so you kind of understand what it would be, we would have like the number of boys here. So 5, 10, 15. And then we would have something like 10 to 12, and that would be there. We would have 13 to 15. We need to make sure there are two numbers for each one. And then 16 to 18. So those are all equal intervals. And that's what the histogram will look like, something along those lines. So our age ranges are all equal, and then we're just having a bar for each one. Okay, so that would be the best one to use for this example. Okay, the next one, select an appropriate display for the percent of students in each grade at a middle school. Well, when it talks about percents, we said that a circle graph or a pie chart would be great for percents because you are comparing how many in each grade part to the entire school. So a circle graph, and just kind of to show what that would look like, we would have this circle. We would say, let's say it was 6th, 7th, and 8th graders. So 6 would be there, 7th would be here, 8th would be there. So that would be the pie chart for the percent of each students at a middle school. And the wedge of the chart would be the percent of what that grade takes up. Okay, so you all do that last one. Select an appropriate display for the number of people who have different kinds of pets. So for this one, I would suggest using a bar graph because for this, you are comparing the different kinds of pets. So cat, dog, horse, whatever. And so each pet would have its own bar at the bottom, and then you would put the bar up to however many people have that type of pet. You could also use a circle graph for this one. If you know how many total people are going to be on this graph and you separate it part to whole, that would work as well. But a bar graph usually is the best one to use for this. Okay, so that's our first type of question. We got a couple more that we'll look at. So this next one, select an appropriate type of display to compare the percent of ethanol production by state, justify your reasoning. So we need to also explain why we chose this. So we've got these different states, but notice what we want to compare. We want to compare the percent of production by state. So anytime we deal with percents, a circle graph is usually the best one. A bar graph probably wouldn't make much sense for this because it's not going to show percents. It would show the amount, but not the percent. So a circle graph because we are comparing percents. circle graph because we are comparing percents for this one. So if we were comparing something other than percents, we might use a different one, but that means we're gonna have our entire thing, which is all the amount of ethanol, and then we would separate it by different state. Okay, so we would continue to do that until we get all the states done. All right, so the last one is to select the appropriate display for the ticket prices from 2009 up to 2012, and then using that, we can predict the price for 2013. So notice what we're doing. We are comparing the prices over a period of time. Comparing the prices of this over a period of time. Which one of those displays compares numbers over a certain period of time from year to year? Well, if you're looking back, it would be a line graph. A line graph. So we would say a line graph because we are comparing prices over a period of time. So anytime we're comparing values over a period of time, a line graph would be best because what would happen is we would have the price over here, and then we would have the year down here. So 2009, 2010, 11, 12, and then we could go to 13. So we would start here and it would go up and then up and then up. Okay, so that would be somewhat, I mean, it's a very rough sketch, but that would be something what the line graph would look like. And so that's our example for that one, probably the best one to use because we're showing how it is increasing over a period of time. Okay, so that's our appropriate displays. So whenever we have these statistics, we need to use a display to show to show them visually. These are the displays we can use. So you can use those displays and select your answers for those practice problems. And that finishes up statistics for us.